Alright, Unit 6, Video 5 on LeChetaliers principle. So what LeChetaliers principle is dealing with is a system in equilibrium. So if we have a system in equilibrium and we change some factors about it, so maybe we're changing the temperature, the system is going to want to adjust to get back into equilibrium. Same thing's going to happen if we change the amount of something. So if we change concentrations, it's going to shift. And same thing's going to happen if we deal with changing the volume of a system. Change the volume, we're gonna mess around with pressure, and it's gonna shift it also. So here what we have on the board is we have a reaction with carbon monoxide gas reacting with water to produce carbon dioxide and hydrogen gas. So over here I have the equilibrium expression value 312, and we've got our delta H value. So if you look at your delta H value, first thing we want to notice is that it's a positive value. So this is an endothermic reaction. If it's an endothermic reaction, that means it's involved in the reactant side. So I'm going to go ahead and put that over here, because what this is saying is in order for this reaction to happen, we not only have to have 1 mole of carbon monoxide and 1 mole of water, but we also have to have 2.85 kilojoules of energy in order for this reaction to happen. Okay, so let's look what happens if we add carbon monoxide to the system. So if I add carbon monoxide into this system, what's going to happen is we're going to get more collisions with water. If we get more collisions with water, what are we going to produce? We're going to produce more of our products. So what we're going to say is that this equilibrium is going to shift to the right. So we're going to say that when we add carbon dioxide, we're going to shift right. Okay, but what happens if we remove hydrogen gas? So if we take hydrogen gas away, the system's going to have to shift so that it can make more hydrogen gas, okay, because we're removing it. So the only way for it to make more hydrogen gas is if we shift it in this direction, so carbon monoxide and water can collide more so that we can get more hydrogen gas. So once again, we were saying this would also shift to the right. Okay, now let's see what happens if we increase temperature. So if we're increasing the temperature, okay, that means we are adding more energy in. If we're adding more energy in, we're going to shift to the right. Because if we're adding more energy in, this is happening more frequently. If this is happening more frequently, we need to make up that difference by using these reactants to produce more products. So these are going to collide more frequently, so we would also say this is going to shift to the right. So we would say shift right here. Okay, well what happens if we add an iron catalyst? If we add an iron catalyst, now remember, catalysts only speed up the rate of the reaction. They do not affect equilibrium. So if we add a catalyst, all that's going to happen is we're going to be doing this faster. So if we do this faster, nothing's changing besides the speed of the reaction, so it's not affecting equilibrium. So we would say that this is no change. Okay, now let's go over here and look at another problem. So we're going to take ammonium nitrite as a solid, and we're going to decompose it into nitrogen gas and water. And water is in the gas round, so is steam. So we're going to, real fast before we do anything, let's look at how we would build the equilibrium expression for this. Okay, ammonium nitrite is a solid, so it's not involved in the equilibrium expression. So therefore, removing it and adding more of it is not going to affect my equilibrium. So here, if I add more ammonium nitrite, since it doesn't have anything to do with my equilibrium expression, there's not going to be a change here. So we're going to say that there's no change because it's not involved in the equilibrium expression. Okay, now what's going to happen if we add water? So if I add more water into here, I'm going to be producing more on this side. So if I add more in, we're going to shift to the left to make up that difference. We shift to the left to make more ammonium nitrite. So if we add water in, we're going to say shift left. Okay, now here, the problem says that we have our delta H value is negative 227 kilojoules. If it's negative 227 kilojoules, that means it's exothermic. Exothermic is involved in the product side of the reaction. So this is we're going to have 227 kilojoules of energy on the right side of the reaction. So what's going to happen if we decrease that temperature? So if we decrease that temperature, we're going to remove some of the temperature. So we're going to remove some of that energy. If we remove some of that energy, we've got to make up that difference. So we've got to decompose this more because we're going to have to produce 227 kilojoules of energy. So if we're removing the energy, we got to decompose more. If we decompose more, we've got to shift this way. So we're going to say that this is going to be a shift to the right. Okay, now decreasing volume. Okay, well remember, concentration has a direct correlation to the number of moles divided by liters. So here, what we have to do is if we're decreasing the volume, we're going to increase the pressure. So if we increase the pressure, because what's happening is we're taking our volume and we're compacting it down. If we compact it down, we're going to push our molecules closer and closer together. So what's going to happen is we're going to get more collisions, higher pressure. If we get more collisions, we're going to increase the concentration of moles. So if we increase the concentration of moles by decreasing the volume, we've got to shift to the side to make up for increasing moles. So in order to do that, we've got to shift to the side with the least amount of moles. So here we've got 3 moles on this side and only 1 mole on this side. So we're going to shift towards the least moles. Shifting towards the least moles means we're going to shift towards the ammonium nitrate side. So we would say this is going to shift left.